This is part 2 of chapter 4. It starts off dealing with skewness. So just an overview real quick. If a curve, we call this a bell curve. If it's about the same on both sides, we call it symmetrical, because it's like a mirror image, one side to the other. If there's more on the right side, you can see here this line drags out. If the mean will be larger than the median, it's positively skewed, positive to the right. If it goes the other way, where the mean is less than the median value, it's negatively skewed. If it's longer to the left, negatively skewed. And then occasionally you have a bimodal situation where you actually have two peaks and a depression in the middle. This one doesn't happen that often. So that's skewness, skewed to the right, skewed to the left, usually those two things. And if it's skewed to the right, the mean is bigger than the median. If it's skewed to the left, the mean is smaller than the median. Now I want to go to, I want to look at the coefficient of skewness, and there's a couple of formulas that we use for this. And I want to look at problem number 14, an even problem on page 104. So let's go over and take a look at that. I have the problem up here at the top. It says listed below are salaries in thousands for a sample of 15 CFOs in the electronics industry. So here are the salaries. It says to determine the mean, median, and standard deviation, the coefficient of skewness using Pearson's method, and determination of the coefficient of skewness using software method. So I took these numbers, put them in a list, and then sorted the list so that we went from the smallest, which was 486, to the largest, which was 586. And then I did a count and found out there were 15 entries. So this is my n value, it's 15. Anytime I need to do anything with n, this is n right here. It wants me to determine the mean, the median, and the standard deviation. So if I total up this list, I get 8,130, and divide that by 15, I get 542. So that's the mean. Since this list is sorted, I can go down to the 8th item, and that's going to be my median. Exactly, the one exactly in the middle. 546 then is the median. Median. Okay, median is 546. Then it wants the standard deviation. Now the standard deviation, I need the difference between the mean and the data point. So this takes 486 and subtracts the mean of 542. I get negative 56. And I do this all the way down. At the median, I take 546 and subtract 542, and I get 4. So I just do the same thing all the way down. And when I add these up, I just did this for confirmation, it comes up to 0. Okay, so this is the difference. Now I want to square all of these numbers. So negative 56 squared is 3136. And I square all of these numbers, multiply it by itself, which gives me positive values. And then I want to take the total. I don't think I have the standard deviation formula. Well, here it is, right here. The summation of the difference squared. So that's 8808 is this top part. And then I divide that by n minus 1. So I'm going to take 8808 divided by 14. And when I do that, that's this right here. I have D34, which is this 8808. I have A33, which is N, and I take one off, which gives me 14. And that answer is 629.14. That is the variance. And as you know, the standard deviation is the square root of the variance. So sum of the x minus the mean squared divided by n minus 1 is 629.14. That's the variance. The square root of the variance, which that's a function in Excel, SQRT of D39 right up here, gives me 25.08. And that's the standard deviation. So that's how I got the standard deviation. Okay. That's what it asked for, determine the mean, the median, and the standard deviation. So I got those. Now it wants the coefficient of skewness using Pearson's method. Well, what is Pearson's method? That's this formula right here. Skewness using Pearson method. You take, this is the skewness, SK. It's equal to 3 times the mean minus the median over the standard deviation. 3 times 542 minus 546 divided by 25.08, and you get a skewness coefficient of negative 0.478. That's B. C, determine the coefficient of skewness using the software method. That's this formula here. So to do that, working on this right side here, we need the summation of the difference between the data point, the mean, divided by the standard deviation, cubed. And let's see how we do that. Up here, here's the data point minus the mean divided by the standard deviation. That's this middle part in the parentheses right here. Okay? And then this number over here is this fraction cubed. That's what this caret E19 is, this guy. And then there's a caret, which means to the power of, and then I put in a 3. And I do that all the way down. So this first part is this inside fraction right here. Then I cube each one of those answers and add them up. And I come up with negative 4.55. That is multiplied by, n, remember, is 15. So 15 divided by n minus 1 is 14, n minus 2 is 13. So here's what it looks like. 15 divided by the product of 14 times 13. You take that answer, multiply it by a negative 4.55, and you get negative 0.375 for an answer. And that is part C. And if you wanted to talk about the skewness, then it is slightly skewed to the left because these numbers are negative. So the curve over on the left side is a little longer than the curve on the right side for this particular item. So that is skewness and coefficient of skewness calculated a couple of different ways.